Right, here's an example of a method here with public access, and it's inside a class with default access. And this is still nonetheless a useful thing to do, because if we look at this package 1, what we've got here is this public class A here with a method M1 in it, and B extends it and overrides that method M1. So because it overrides, that means it must have the same or wider access, and because that's public, that means that must be public as well. So that's got to be public. Now if we come to this second package, package 2 down here, now there's no direct access now to M1 from package 2, nor is there any access to class B. However, there is access to A, and of course a variable of type A can of course point, or refer I should say, to an object of class B. There's no problem with that. And so if we could obtain such a variable, then calling a.m1 on it would result in a call not to the method in A, but to the overridden one in B, because A would refer to an object of class B, and therefore that is basically what happens here. This is just a way of quick way of getting a reference to an object of class B, and that's what happens, because if you look at this, it returns new B, and this return type is A here, so that's okay because B is a subclass of A, so that's going to be okay. That has to be A, not B, because we've got no access to B down here. We can't refer to B because we're in a different package. And so, well, that's basically what this says down here. A and B are in package 1. C's got no direct access to M1 in B. However, because B extends A and overrides the M1 in A, which C does have access to, and of course if C can somehow or other get hold of a variable of type A, which has been set to refer to an object of class B, and it's going to be B's version of M1 that will run when it's when C calls it, and not A's. So even though there's no direct access to this, it can still sometimes get run because of the overriding which takes place. So that's how it's done. Now we come to protected access, and protected access is very subtle, and many people get this one wrong. Okay, let's deal with the easy case first. If you're in the same package as the protected field or method you're trying to access, then it's no problem, it just looks like default. The default case, the default access. So that's easy. Now, if you're in a different package, then what matters is how you're accessing the protected field or method. First of all, let's suppose you're in a subclass, say S, and we call the class of the thing that you're trying to access T. So we're trying to get at a protected field in a class T from a subclass S, where the code is. Now, if you're using inheritance to access the field or method, then it's okay. It's nice, straightforward, it works. But, and this is the one that people always get wrong, if you're being passed a reference, it gets a lot more complicated. Supposing you're passed a reference variable of type R, and it refers to an object of class O. So right, O is going to be R or a subclass of R. Then if R is S or a subclass of S, then it's okay. Otherwise you'll get a compiler error. Okay, I told you this was subtle. In effect, what's going on here is it guarantees that this class S that you're lying in lies on the inheritance path from O, where the reference refers to T. Okay, so that path from O to T goes through S. That's basically what this is guaranteeing. Alright, so what about interfaces? I said you're passed a reference variable here. What if you're passed, that thing refers to an interface? So, you know, R might be some sort of interface I. Now, if you're trying to use that to access the protected method, then the thing to bear in mind is that all the methods of I are public. Okay, so what you must be doing, of course, is casting that reference I to some class and using that to get to the protected method of T, or the protected field, of course. Now that cast has got to be S or lower in the tree, otherwise you're going to get a compiler error for exactly the same reason. And of course the cast will of course cause a runtime check to be done to make sure it's okay. Right, now that probably sounds all a little bit confusing, so I'm just going to give you an example here to illustrate what's really happening and make it a bit clearer.